Hey guys, welcome back to the channel. So today we would be solving this daily Leetcode challenge, which is count square submatrices with all ones. So we are given an n into m matrix of ones and zeros, and we have to return how many square submatrices can be formed. And this submatrices should have all the ones in it. Okay, so let's consider this first example. Now for this we can form 10 squares of side 1, which is this individual ones, and you can count here that they are 1 2 3, 3 plus 4 is 7, and 8 9 10. Okay, so there are 10 squares of side 1, and then we have 4 squares of side 2. Okay, let's calculate them. So yes, this is the first square of size 2 of side 2, and then we have this second square of side 2. Again we have this first square from this bottom column, or I would say bottom row, from this bottom row, and this second square from bottom row, and then we have this 4 squares, which is correct, and we have one square of side 3, which is this. Okay, and notice that we are not considering this part because here it is 0, and we are asked that all the cells in the square should have only one. So let's see how we can solve this. So now let's say we consider this example. Here it is 1 1 1 1, then 1 1 0 1, then maybe 1 1 1 and 1. Okay, now what we can do is, for every cell we can check how many squares can be formed starting from this particular cell. So let's say the number at this position is 1. So by default we will increment our answer by 1 because this is always a square of length 1. Now we know that we can create a square starting from this cell of size 1. Okay, now let's check this for size 2. For a square of size 2 we have 2 rows and 2 columns. Okay, so again we will start from here and we will iterate, and we can see that for 2 position there are 1, which means that yes, this can be considered as a side of this square, and there is a possibility that we can create a square of size 2. Okay, then we checked it for the first row, but as there are 2 rows, again we will start for the second row, and again we will iterate, and yes, these both are 1. Okay, which means that 2 into 2 square is possible. Yes, it is possible. Okay, so we will increment it by plus 1, which means that first we are creating a square of side 1, then we are creating a square of side 2. Great. Let's see now, can we create a square of side 3? Okay, now let's check this for side 3. Again we will start from this same cell. Let's go ahead, and 2 is possible. Let's go ahead. Now we are considering this for side 3. Okay, then this is 1. So in the first row all the 3 columns are 1, which means that we can still create a square of side 3. Let's move to this second row. So the first 2 columns are 1, but we see that the third column is 0. Okay, but we are trying to make a square of side 3, but here it is 0, so this is not possible. So we will not add anything in our answer, and since the square of side 3 is not possible, we know that the square of side 4 is also not possible, because the square of side 4 will always include this, and since this is 0 we cannot calculate this. Great. Now let's move ahead, and we will keep doing this for each of this cell, and we'll calculate the answer, and in this way we will get our final answer. Now let's try to see what is the time complexity of this solution. So we will have something like a for loop which will iterate over the rows. Then inside this we will have a jth loop which is iterating over the columns, and as we now got our ith and jth cell, so for this we will check if it is possible to make a square of size 1 2 3 and so on. So we will iterate from, let's say, 1 to, let's say, any number which is the minimum of RC. Okay, and then for each of this we will iterate over all the rows, like the first row, second row, third row. So it would be for all rows, and let's say this is k, and it will move for all rows. So the time complexity would be O of n raised to 4, because we are using 4 for loops which are nested and would iterate all the rows in the worst possible case, but this is not acceptable. So can we do better? Let's see. So now let's consider this same example, which is 1 1 1 1, then 1 1 0 1 1 1 1 and 1. Now instead of this starting cell, we will check how many squares can be formed such that they are having this bottom right corner as this particular cell. So it will have this particular square, let's say, then this square, then maybe further squares. So for all these squares, this is the bottom right corner of this particular squares. Okay, so for this we will consider every cell as the potential bottom right corner. So what we can do is we can maintain a DP matrix, and here for each of this particular cell we will consider how many squares can be formed such that this is the bottom right corner of that particular square. So starting with this first row, we know that this is always a corner of the square because we cannot extend it further in the upward direction. So we can write this as it is in our DP matrix. Okay. Similarly, for this first column, we know that we cannot extend it further on the left side. So we can write it as it is. So for the remaining cells, let's try to calculate the value. So let's say for this cell, here it is 1, and we can see that in the upward direction it is 1. In the left direction, this is still 1, and in the diagonal direction also it is 1. Here this diagonal means that we are able to create a square such that this is the bottom right corner of this particular square. And here how many squares can be formed having this as the bottom right corner, and this is 1. Okay, so since in the top, left and diagonal direction we can create a square of side 1, and this is also 1, which means that this particular part, like this part can be expanded with this square, and hence we would be able to form a square having the side 2. Okay, so what we did is we took the minimum of these values and add 1 to it, because here it was 1. So it would be the minimum of this one would be 1 and plus 1 because this is 1. Then we are getting 2, and we do plus 1 because this itself is a small square, hence we added 1, which means we got our answer 2. Okay, for this cell this is 0, which means that whether we can form the square in the upward and diagonal direction, but this cannot be added to that particular square since this is 0. So we would be having 0 here. Now moving to this cell, here again we can see that in the upward direction here it is 1, which means that here we can form a square which is ending at this point, and the side of the square is 1. Okay, and in the left part we can see that we cannot form any square such that this is the bottom right corner of the cell, as it is 0, and hence we did not need to check this diagonal part, and we can simply copy paste the value as it is, which is 1. Now for this cell we will check in the upward direction we can create a square of side 2. Here we, in the DP array, we know that we can create a square of side 2 such that this is the bottom right corner of that particular squares. So in the left part we can check that here it is only 1, because on the left side we can create a square having side 1 only. Okay, and the diagonal part here also it is 1, which means that here it is a square of side 1. Hence we can expand this further, as these values are non-zero values, and we can take the minimum of this. So the minimum of this would be simply 1. So total it would be 1 plus 1 for this value, because here it is 1. Then we get our answer as 2, which means that this is a square which can be formed, and this is another square which can be formed. Okay, great. Now moving towards this, here also in the upward direction it is 0, hence the minimum of this value would be always 0, as this is 0, and hence we will just copy paste this value as it is. so it would be 1. And now for this cell, we can see that in the upward direction we can create a square of side 1, and in the left direction we can create a square of side 1, and in the diagonal direction it is 0. Hence the minimum of these values would be 0, and as this is 1, we would add 1 to it and it would be simply 1. Okay, so the total number of squares which can be formed are the summation of these all values, which is 1 plus 1 plus 1 plus 1, which is 4 plus 1 5 6 7 8 9 10 11 12 13. So we can form 13 squares, and let's try to verify this. So we were having our example as 1 1 1 1 1 1 0 1 1 1 1 1. So 1 2 3 4 5 6 7 8 9 10 11. So first we have 11, then we have this 12, then we have this 13. Okay, so the total is 13 and we cannot form more squares. So yeah, this is our answer. So let's try to implement this in our code. So first let's keep the track of the rows and columns of this matrix, which is matrix.length. Then I have the number of columns, which is matrix of 0 dot length. Then we will maintain our answer variable. Then we will maintain our dp array of this same size of matrix, which is n cross m. Okay, then we will iterate over this matrix, so it would be starting from I to n. Then we will iterate for the columns for this row, so it would be j is less than m and simply j plus plus. Okay, now we know that for the first row and first column we were copy pasting the values as it was present in the matrix. So if our row is 0 or our column is 0, then what we were doing is we were just copy pasting it in our dp array, which is dp of I j equal to matrix of I and j. Okay, then if this value is 1, then simply we will just increment our answer and we can just continue. Okay, so we have handled our first row and first column. Now let's handle the case if this matrix value is 0. So let's say I and j, here it is 0, so we can just continue from here because this cannot be a valid corner of a particular square. Then what we can do is we can fill our dp array based on the minimum value of this dp of I minus 1 and j minus 1. This is the diagonal part. Then we will take the minimum of this left cell, which is I minus 1 and j, and the minimum of dp of I and j minus 1, which is the top cell. And since we are getting rid of this 0 values, so we are left with only cells which are having 1 in them. So we will increment by 1, and then in the end we will just increment our answer by this dp of I and j, because now at this point we got how many squares can be formed such that this is the ending cell of that particular square. And what we can do is we can just simply return this. So yeah, this should work. So let's try to run this. Okay, so let's try to submit this. So yeah, it gets accepted. So thanks for watching and subscribe to the channel for more such videos.